as well. Very nice. We need certificate for Kelly.
This is Nico.
Hi, Karen. Nice to meet you.
Nico just joined us.
Yeah.
So hi, nice to meet you. Hi, Ryan.
Hi, Marco.
Stop. Hi, Allison.
Hi.
Nice to meet you.
Now we are close, so we can share.
Hi, Allison. Nice to meet you.
Ja. Legen wir los, oder? Jo. Nice to meet you.
Hi, Allison. Nice to meet you.
So I wonder what he will learn today from the Agile course.
Dead.
You guys want to take a seat, or are you comfortable standing there?
I'll stand back here because I have the dog.
It
So.
looks busy around.
Or do you want me up there? Okay.
No.
Can
It makes
I
it better when Chris is out
pour
there.
beer and
he's
water
going
and then I'll
back
move to the
with-
front?
Können hätte man Patrick mal gebraucht, aber wer heißt immer mit dem Logo?
She's downstairs.
Das ist wieder gemacht. Ja, der hat wieder Feedback gefragt. Aber irgendwas stimmt nicht so ganz. Wenn ich das Logo so angucke, muss aber noch ein bisschen größer werden. Oder haben wir so den Sorge gemacht?
Where's the beer opener?
He opened it for me.
With his teeth?
No, I can do it. That's an easy task.
Sven, das ist mit dem
Just use two.
hellen
Yeah,
Hintergrund.
of course.
Da hat sie das Problem.
Ja, nur noch mehr Alex. Aber
Okay, another one?
No, just one.
Müssen wir den Ton zu
Here, baby.
Yes.
Are you okay holding her? Or do you want me to?
Noch live stream gemacht? So we are online now, so please behave. Somehow.
Let's get the
Can
party
you see
started
how many
now.
people are watching?
There should be an analytics thing there.
Ellie's going agile too.
Yes.
Okay, so I guess we're gonna start. So thanks for everyone, for those who came here today. My name is Sven Becker, as you might know or even might not know. We're here today at Acellere, a really cool startup. So, thanks Acellere for providing the venue and the refreshments. We're also kicking off with our Scaling DevOps Global Group, which is a group focused on all DevOps enthusiasts. And we're combining it together today with our Scaling Agile Global community. And to give you guys a quick overview of Scaling Agile Global, Peter and I, we founded Scaling Agile Global 2 years ago. We started off with one group with 20 members. Today we are around 16 members in 14 different countries. And today in parallel, our Hungary chapter is actually doing a meetup. They've got around 50 attendees, and they're going to talk about impressions from the SAFE Summit, which happened around 1.5 months ago in the Netherlands. Also today we have good friends from KEGON AG, Carolina Schmidt. She'll be talking a little bit about safe DevOps. We have Marcus Holzimer from Acellere. He will share a little bit about the Accellere's Agile and DevOps approach. Really looking forward for it. And yeah, thanks for coming. And Peter, maybe if you want to talk a little bit about the future, where we want to be, that'll be great.
Of course. So thank you very much for joining today. You know that SAFE and DevOps are coming together. You have seen in SAFE that the part of DevOps coming in, and if you know this for a long time, Agile was always part of DevOps. Where does Agile start? In the DevOps area. So it comes together, and this is why we're here today meeting of both teams. So what we have to do is, as we said in the past as well, we would like to connect the dots in the future. So have one community communicating to each other. That's our goal for the future. And said this, I would like to hand over to Vishal. Vishal, he's the host for today, and he would like to talk about DevOps and how this happened here in Acellere. Vishal, please.
Thank you. Thanks.
Welcome.
Hi everyone, Vishal here. Happy to get everyone. Beautiful day. I think we should be doing this outside on this lovely day. But just a little bit about us. Why did we create the company? We created the company because we believed there was this huge opportunity in this whole agile world where teams are becoming leaner, the processes are shrinking, time to market is increasing, and Atlassian's pretty much thought about the process, right? Jira is the standard. People use it for sprints. But a very important stakeholder in this agile process, the developers, have been left out. There are no good tools in the market that actually completely adheres to the agile development Scrum cycles for developers, which means as you write software, you get instant feedback on how your quality is. And you're pushing the boundaries in terms of not only do you get feedback on the problems, but you also get hints on how you can solve them. And that's, I think, the missing link in the agile world, which we've tried to plug in with our platform Gamma. And I think we perhaps complete the agile workflow puzzle. We've been having some discussions, and I think we embody pretty much what agile is all about. And during the course of this meetup, I'm happy to talk to you, share more about what we're doing, and learn from fantastic opportunity. So thank you so much. Peter.
Soon to be involved.
Yeah, yeah, coming soon.
So this was the first introduction, and now we hand over to Marcus, and he will talk about what happened here at Acellere with DevOps. Thank you.
Thank you. Yeah, thanks for inviting me. And I would like to share a little bit about how we do DevOps here at Acellere. But before I start, I would like to get a little more to know about how much you know about in the audience. So who of you has an IT background in any form? Who of you is working in DevOps? Okay, great. Yes, so we are a software tool provider. Our tool is called Gamma. What we do is we analyze, or we provide a software analysis platform. This means we do static analysis. So in general, how it works is people give us their source code, or give their source code into our platform. We analyze the code and give all kinds of findings back to the customer. And if you look at this only a very rough overview on how Gamma's architecture looks like, it's more or less like a classic three-tier architecture. So we have a front-end part, which is written in Node.js, we have a middleware part, and then the back-end where all the analysis happens. And yeah, the interesting part about our platform is that we offer both software as a service and on-premise. So our customers install Gamma in their data center, and we host it for them as well. And this has a lot of challenges for the DevOps part and how we deploy our code, because it makes us a little bit different to how other startups work, especially SaaS startups that have a lot less challenges in some areas than compared to what we do. And another interesting aspect is that Gamma itself also fits into the DevOps cycle. So Gamma supports the DevOps of our customers, and we use DevOps tools in our own development. So it's kind of a mixed approach. Of course, we also use Gamma in our own DevOps. That's also what I want to share later with you. So how does our product development work? We work with 2-week development sprints. So this means the developers get 2 weeks time to do their coding. After that, we have 1 week of integrated testing. This means we bring all the different components together. There's about 5 different teams working on 5 different components of Gamma. Like on a large scale, of course, it's getting to smaller teams as well. And we found out that a lot of issues come during that integration phase. And I believe that's a challenge that a lot of larger development organizations have, that many developers develop their feature on their local laptop, and they think it's done if it works on their laptop. But that's not when it's actually done, because it's only done if it works on all the different platforms that we're offering. I think on the previous slide, we mentioned a little bit on how many different versions there is. So out of my head, we support 2 versions of Ubuntu. We support 3 versions of CentOS and Red Hat, so different operating systems. We support Windows 10, Windows 2012 and 16 on the server edition. On each of those platforms, we offer different installation methods. So native installations, Docker-based, Docker Compose, Kubernetes, and then we support different kinds of auto-scaling environments, like the auto-scaling on Kubernetes, on Docker Swarms, on the cloud environment. So that's just a massive integration piece that runs on different hardwares, different setups. And this is why this is a very critical phase for us. What happens when we do a feature freeze? This means development stops. We bring all the components together, everybody tests for 1 week. Then we do a code freeze, so we decide what features are ready to become part of this release. And then we do 1 week of system testing, which means testing focused really on the customer. So we test it from a customer's perspective. We do all the final installations of the release candidate on all the different environments on the cloud. QA team tests it. We do a big bug bash actually, where everybody tests it as well for half an afternoon. And then week 5, we release and deploy. And in parallel, we start developing the next release. So it's kind of an overlap. And we can do that because we have a mid-sized development organization. We have about 40 to 50 people in our R&D. Out of this, 4 people are pure QA, and 2 people are pure DevOps currently, and the rest is developers.
Oh. So when you're saying, you have developed for 2 weeks, and you have 1 week for integration testing. So all the developers doing the integration testing, they stop developing at the time, do testing.
Yes. Okay. And we did a lot of experimentation actually with this. Of course, we didn't want to have this week, so we tried to get rid of it quite often. Yeah. But we found out that there's so many bugs usually found in that phase that there's no efficient development possible while that integration phase happens. Okay. So typically release for us is about 40 to 50 internal bugs that we find in those 2 weeks. There's almost no external bugs, so our QA is actually working quite well, like if you look from customer perspective. But in terms of development organization, they cannot, those 50 bugs cannot be fixed while the next development starts. Right. And we want to, I will talk about a little bit more about how we want to evolve in the future later. Of course, we would like to find more in that phase. We don't need this overhead here, but this is an ongoing challenge for us. How can we bring this time down and find more issues in here? Yeah, and in general, it is very important to find bugs in here, shift left, because if you find it later on, then it's more expensive to solve. Yes. Yeah. And also, if you look at this picture, especially like some people were out of the DevOps area, it looks kind of slow, because DevOps everybody's about we can deploy in seconds and so on. But this is because our software is installed with our customers, and we work with a lot of really large customers like banks around here, automotive companies, and so on. So they cannot deploy and release shortly. Like they usually, our typical customer does a new deployment maybe half a year. So every version we ship to the customer, we must expect that it's used at least half a year by some of our customers. And that makes it a big challenge in terms of QA to make sure that what leaves us, so when we give out a release, that it's tested and works. Internally, actually, I can also speak about it later. We can also deploy in a few minutes to our cloud environment. So that is not the challenge. The difficult part is how to bring our software to our customers. So another question is, on 3 weeks now, you might integration testing between the different software components, and then you go for system testing. This is on the operating system, is it? For us, it's a different phase because this is without the developers. So it's more like an extended integration testing, I would say. But terminology is a little bit, vague in that area. Okay, thank you. More questions on this? Cool. So now it becomes a little bit more technical. How do we develop technically? We are hosted on GitHub. Don't smile. I try to keep it as simple as possible. So we follow a classic Git flow approach. I think it's widely known. Because if you look at our code base, how we manage our code, we have to develop on multiple different versions in parallel. So we have a master branch, that is the last version we ship to our customers. Then we have a release branch, that is the current release candidate. And then we have features that did not make it yet to the release candidate. So there's like different tracks in parallel and then hot fixes to all of these. And how we do this, we have different branches in Git, typically feature branches. Every commit, of course, is unit tested automatically. So all the unit tests run for every commit. Once some developer thinks this feature is ready, so So he thinks he finished his development, he did all his dev testing. He will open a pull request on GitHub. This means he requests his feature to become part of the usually development branch, the main development kind of line. And this automatically triggers a quality review. So this is where we do most of the quality assurance on the code level. So this opens a pull request on GitHub, and then it's both manual review and gamma review. So our own tool is run against the pull request to make sure the quality goes up with every new feature and doesn't go down. And one unique feature about our tool is that we also look at software design, because very often, if you do this code review only manually, if you have experienced developers, they are quite good in finding bugs or making sure this code is clean. But even an experienced developer, especially if he doesn't get the time, it's difficult for him to assess the overall architecture impact of a change. Like one example would be a direct cyclic dependency. Let's say somebody adds a component that introduces a cyclic dependency somewhere. Almost no developer has all the dependencies in his head and can immediately see it. So those things slip through usually. And this we can solve with Gamma. So this is how we also architecturally make sure the changes fits to the overall picture.
So architecture means for you the integration to other areas and to follow up with them, right?
Yeah, it's on the software level. So on the software architecture of this component that it fits into this architecture. Yeah, once it's approved, it gets merged to the dev branch, and it triggers a whole suite of automated test cases. So one thing that we're using is Vagrant. I'm not sure if you are aware of Vagrant. Yeah, it's a tool to optimize the creation of virtual machines. And that we use because we have to test it on all these different platforms in parallel, like those 3 different Windows versions, 2 different Ubuntu versions, and so on. And we do it via Vagrant. So Vagrant spins up all these different virtual machines, and then we run all the different tests against it, which is like JMeter, for example. We're also working with Selenium on UI testing. We have our own test scripts that we wrote. And all this goes against all platforms in parallel, which is quite powerful. It took us quite some time to get there. And we also use Docker in parallel, not on Vagrant, but also Docker will automatically spin up these different Docker instances, and all the tests will run against this as well. And only if this passes, it becomes part of the sprint branch, which is like the newest release candidate, more or less, that we want to ship to our customers.
Is Gamma a code review tool or something else?
Yes, we do static code analysis. So it statically reviews the code, finds code issues, it finds duplicated pieces, it finds certain architectural problems, and it also looks at metrics.
Something like SonarQube.
Yeah, SonarQube, but better.
Much better.
Yeah. So you talk about early feedback in the development cycle. What does it mean here? You have your blueprints in there.
So it's because we try to do these tests as early as possible. Like unit testing, we do immediately when it's possible. This types of reviews we do earliest as possible, and also this automated integration testing we do as early as possible from our perspective. As soon as the feature is part of the dev branch of the main development line, it should, in theory, be deployable to all these different versions. That's what it meant, yeah. Yes. So if you look at this explains a little bit more what we do in this integration testing phase, and that most of it I touched before, and we still do manual smoke testing. Actually, we have 4 testers in India that constantly do manual testing for the parts that are not automated yet. We have a CI plugin, so that just kind of explains how we do the quality assurance of these pull requests that we saw earlier. We use Jenkins internally, so Jenkins is used to orchestrate all these different reviews and deployments and builds. And then artifact creation is actually the step that happens here after the approval. So after this is approved, we create all the different installers, the different Docker containers, we deploy to Docker Hub, to all our internal repositories, to make it ready for integration testing. On Vagrant then would pull it from these different repositories and then do the different test cycles. And this also I've touched before. Like a huge issue that we had in the past, like 1 year ago actually, our biggest issue was how can we make sure Gamma installs on all these platforms? It sounds like an easy problem, but it was actually extremely complicated because, like as I explained, we have like 5 to 10 different versions of operating systems, but even those versions are different for all different customers. Like many customers have their own base image that they're using, or they have some pre-installs that are done on the machine, or they have some old, not updated Java still installed because of some compliance reasons. And in the past, this made our installer fail quite often, especially in the first half year. This is why we heavily do installer testing, like with different configurations, different setups, and so on. Next is automated deployment to the cloud. So our cloud environment is different to our on-premise environment in a sense that we deploy all the different components separately and all is auto-scalable. So everything needs to run on one instance or n instances. And what we do is we automatically, so we have a test staging and production environment, and we automatically test on the test dev environment, and integration and release testing is done on the staging environment, which is a mirror of the production environment.
When you say automatically scales in the cloud, does it add more CPU and RAM or whatever?
No, it adds machines.
Add machines?
Yes.
And they work seamlessly together?
Yes. So all the different, like the Gamma frontend, for example, is a Node.js application. And it's not much lower during night, it runs on one machine, but then it would bring up new machines as a load balancer if they have more signups, more users. And we have that for every layer actually.
Yeah, our cloud architecture is really well designed. It's completely scalable to infinite.
Yeah.
With no performance.
Yeah.
What does all the layers means?
Like all the different software components of Gamma, like logical components, like front-end, middleware, back-end, and surrounding systems. We also have some microservices now.
Okay.
So all these things are scalable, and those have kind of slightly different test scripts compared to the on-premise version. Because we need to do load testing, for example, concurrency testing, those kind of things.
Okay.
So you have a cloud version of the software as well?
Yes. Yes, yeah. You can find it on mygamma.io. That's our product website currently, soon embol.io.
And that's the difference. The Sonar Source has Sonar Cloud, but actually it's not technically a cloud. They still download the installer on your machine. So what's the point of cloud? They only send data to the cloud, and for that they charge you a lot of money. We are a clean cloud static analyzer, a clean on-prem static analyzer.
What languages do you support?
Like most of the major ones. I think
17 languages today. Some better than the other, full disclosure.
And that also, this also explains why we need this automation. So what we do is we install it on these 15 different environments. I think 15 is the latest count. And then we do analyses of all these different languages. So we trigger 15 scans, some run in parallel, some sequentially. And then we do data validation. We see if the scans finish, if all the data is there. We look if the UI loads, if the API times are acceptable, all of this.
And our newest language?
JavaScript,
yeah. So that we added this week.
Actually, we did support JavaScript, but we're going to be the first static analysis platform in the world that also supports design issues for JavaScript, and no one does. Because JavaScript, as you all know, is the Wild West, right? And all tools, including Sonar, just do code issues. And we think code issues are symptoms of poorly designed software. So we've gone right to the heart of the problem, and that's how we are different and therefore powerful.
Yes. And of course, results for each analyzer need to be the same, no matter where you run the scan. If it's on our cloud, on a local laptop, everywhere, it needs to have the same results. That's also what mentioned here with the data validation. So that is also a big part of our testing.
And our performance on an apples-to-apples machine, we are at least 4 times faster than Sonar Source. And we generate at least 3 times more data. So you can do the maths.
Yeah. And yeah, some more tools I mentioned that we're using Ansible, Vagrant, CloudFormation for infrastructure automation. Yeah, but we are more and more going into Vagrant as direction actually. Because another challenge I didn't mention before is our development team is split between India and Germany. And one big challenge we have in India is they don't have good internet connection in our office. Yeah, it sounds like an easy problem, but it makes DevOps a little bit more challenging because you cannot build anything on cloud because they will never be able to download it. It takes them hours to download a new build. This is why we have like the whole thing copied 2 times. We have like the whole Jenkins in Pune and on the cloud, and you have to keep it in sync so the config is the same. So that the people in Pune can use their local Jenkins, local builds, and we use the cloud ones for our outside facing and German development. That is another interesting bit.
We know Loon Boon.
What is it?
Loon Balloon. Google floating internet.
Yeah.
Loon Balloon.
We need Loon. Yeah.
Satellite.
No, it's hot balloons. One balloon space internet. Yeah.
But isn't there microsatellites as well? Like 20,000 microsatellites?
That's separate. I think that's
Okay. That will make our life
satellite-based DevOps. That's the next thing.
Yeah. Yeah, this is kind of a summary again on like DevOps is all in a cycle. So of course we have these overlapping releases. It starts with development, we test, we review first. That was also a phase we didn't have in the past. We now do very strong UX, UI review to make sure the experience is also there for our customers. Automated testing, review manual testing, and then we release. So all the releases go to this kind of DevOps cycle. Yeah, that's actually a thing we introduced quite newly. So after the 2 weeks when the development finishes, we have a big session where the developers demo what they did to all the stakeholders. So we bring together our UX, UI, product team. We want to bring sales as well. That will be the next step. And of course, solutions. And so that everybody knows what is coming. Also, the testers know what is coming. And only after that kind of demo, we go into the rest of the test cycle.
You know, if we talk about Agile, then this review is done with the customer. So you're talking about internal customers. What about external customers?
Yeah, we thought about it.
Actually, we started that in Japan. So we actually release in Japan, because of our customers in Japan, we actually we've added 1 week to this right now, so that 1 week from our launch, they test it. And then we fix feedbacks, and then we do the global release. So literally our Japanese customers are our customer facing team. Because one thing we found is that they are really, really thorough customers. I mean, we thought customers in Germany were thorough, but trust me, the Japanese are something else, which is great for us, and they're happy to support.
Yeah.
So that's where our so-called customer testing happens now. We added 1 week, I believe, to the release cycle, right, Marcus? From
only for Japan, actually. In Germany, we don't do it. Only for Japan.
Correct, but we have taken that as a customer feedback into the process now.
And other than that, usually all our features come in German. It's called feature request. So everybody can request a new feature, customers, sales, developers. And of course, whoever did the feature request, he will be part of the demo to make sure that the feature matches his expectations.
Yeah.
That's how we handle it.
That's good.
Yeah, actually, we track it completely through the system. So it started a feature request, we transform it into a task or a story, and then it goes through. It's linked with the test cases.
It's fully agile, right? We use Acellere.
Yeah.
Perfect.
Really,
Yeah.
Yeah, this goes a little bit more into releasing. So one challenge we also had in the past is that we want to release without downtime for our customer. And yeah, one well-known approach for that is blue-green deployment that we also adopted. So when we want to deploy a new production environment, we will not replace the old one, but we will spin up a completely second production environment. We will do some last testing on it, smoke test and automated testing. So we make sure the scans run and at least the minimum set of test cases is running to confirm really this is working on production itself.
Is this for on-premise or for the cloud?
For the cloud.
For the cloud.
Yeah, on-premise we cannot control what our customers do. That's the challenge. But for our cloud, we work like this. Spin up a mirror of production. We do last testing. I usually test personally, actually, with the other leads. And only that works, we kind of change the DNS endpoint so that the traffic routes to the new one.
It's completely on the fly. So imagine static analysis happening for your scan, and then we switch on the fly without any downtime.
Yeah.
That's really cool.
That's actually the interesting bit, that our scans, they run between 30 seconds and 3 hours on the cloud. So a lot of scans still have to finish against the old DNS. So usually we keep this around for half a day or a full day longer to finish the scan, but route the front-end traffic already to the new environment. This is how we can seamlessly upgrade.
I think this is something we are very proud of, because it's like static analysis scan running, and then we're switching this on the fly with a new deployment, which is literally world class. It's not just we do it well. I mean, we are at par here with companies like Google and the best. But we don't talk as much because we are in Germany. We are modest. But this is very cool.
So how do you deal with TTL that is in
I mean, we keep this one alive as well for a day. This is how it works. So some traffic is still going against the old environment, some is against the new one, and then after a few hours, typically everything is routed to the new.
So how do you ensure that the scans already running are routed to the old environment? So
those scans we scan via IP. So we'll directly connect to the IP endpoint. So it will still go to the old IP, and then it will use a new IP in the future.
Yeah, we have thousands of users who use our. So we also have a free version. So lots of open source committers now actually use this to develop some of the biggest open source products in the world. And so we have hackers, we have open source hobbyists from some of the biggest companies in the world, in Silicon Valley, in Japan, and Brazil, who use Gamma on a daily basis. And that's growing. And we've not even done any advertising for it. It's just word of mouth that's spreading. And that's also gives us a lot of information on how customers use Gamma, what they like, what they don't. Right?
Yes. We would love, yeah. So I personally, from an IP perspective, my life would be much easier if we would only do it cloud. Because this is about 20% of our effort, and 80% of our effort go into on-premise installations actually, which is, yeah. Also at the beginning, I underestimated this part on how thoroughly you have to test what you ship to the customer. Because otherwise it will hit us in support and in solutions. Because if it doesn't run, we have to travel to the customer, and this takes much more time than adding it to the test phase. That was a learning that we had.
So this was the problem that Docker was supposed to solve, right? But it doesn't.
No, with Docker we have less problems, but most customers, they don't use Docker yet. So for now, it only added to our complexity, because now we also have to support Docker, which is even more than we had before.
Yeah, but I agree with Kubernetes and Docker. This will, some of the new customers, especially large financial institutions in North America, 4,000 developers, they want to spin up Gamma on the fly. It'll only work with Docker.
Yeah, so Docker is our favorite way of installing now since 2-3 months. So we push our customers for Docker, but we still support all the native installers.
And before you go to the blue one is the old one, the green one is the new one, right?
Yes, so we switch back and forth.
Yeah, and before you go to green one environments, how much time you take upfront for testing? If you're testing upfront all the time, 2 weeks development, then testing. Do you do final testing in here before you go to green?
Yes.
Like a month or whatever?
No, this is like 2 hours, final testing. So we deploy it and then we test 2 hours. So this is how long our automation scripts, at least the most important ones, need to run. And then all the leads personally look into their accounts if all the data was migrated, and then we just view out the traffic.
Okay.
Because we're quite confident that the product is stable at this time. It's just about some, like we had it in the past, and that we had some configuration mismatch. We don't have that anymore, but there's a very low likelihood that there's some configuration change that we didn't notice, and this is how we want to patch it. But all the rest it usually just works.
And we're completely on AWS. So on a cloud partners AWS.
Any more feedback questions on blue-green?
And how are you doing on the premise then? If you send it to a customer, you have an installer that take care of the old one and so the new one.
Yeah, so we have a self-service portal.
Yeah.
And we have different installers.
Okay.
There's mainly 2 installers, and then there's different installers for the different plugins and integrations that we offer. So we also ship ID plugins, we ship CI/CD plugins. Yeah, and a lot more. And then they have a portal and they can download all these artifacts. This is why by testing is so challenging. You need to update all this at the same time. Publish, I think, 15 different plugins and integrations, different versions of installers, Docker on the Docker Hub, and all this needs to work.
Around the world, yeah. And I think that's pretty credible for a small company like ours, and we're not even Silicon Valley based. We're actually headquartered in Frankfurt. I think the team, what we've done, sometimes it helps when you're working in isolation because you can come up with really creative solutions. You're not swayed by what's hot in the market. And I think that's why we've been so fast. And some of the stuff we're doing is, in the development, is really world class.
Yeah.
And it's truly agile to keep up with the team.
And how often you bring out the new cloud version then?
It's in sync with our releases, so once a month.
Once a month.
And then hotfix, sometimes if it's really critical, we can deploy hotfixes within a few hours, but usually it's not required.
So the cloud is once a month, and the on-premise is mostly half a year.
No, we ship releases every month.
Okay.
But it's up to our customers when they do the upgrade.
Okay.
So sometimes some customers do it every month, some customers do it once a year, half a year. We don't have any control over that.
Some customers you have to really chase.
Yes.
Because they want a feature, they're not using the new version. So we really have to harass them saying, hey, we've got this going, come on.
Okay.
Yeah, and this also makes our upgrade process a little bit different, and testing of that is an entirely new story. Okay, make sure all these different versions are still upgradable automatically.
And what agile methodology has you picked? Safe is much too big, I guess.
Yeah. I think we adapted. So we use a little bit of Scrum because we have these sprint models, but it's highly adapted. So for me, it's difficult to say what methodology. Because we've optimized. So we started with some standard Scrum. It's 2 week sprint very optimistically, and we adapted our method. And so now it's customized.
And you're working with different teams, one in Germany, one is in India. How they work together then? Is this one meeting in the morning, or how you do this?
So I'm the only one that develops in Germany. So I'm not taking part. So they have daily stand-ups, but I'm not taking part there.
Yeah.
So it's mostly from India actually.
But we have one central Jira, one central Git. So we have a DevOps is pretty central.
Yes.
And that's what it's truly distributed development. And we have someone in Berlin sometimes develops. But it's a classic example of distributed cloud DevOps infrastructure. None of our DevOps platforms are on-prem, right? The central thing is all on cloud.
Except we have a few big machines in India because of the network issue.
But in general, the repo and everything is GitHub Cloud,
yes.
Atlassian Cloud. So we don't do any of the core infrastructure on-prem anymore. We actually migrated from Jira on-prem to Jira Cloud as well. So everything's on the cloud.
And from the methodology, then in SAFe, you have this big room planning thing where everybody in the room stays together and talks about what will be achieved in the next release, etc. Are you doing something like this as well?
Yeah, that happens.
That we do join, so it's long meetings, it's screen sharing.
Yeah.
Because product management is split, so we have one product manager here, one in India, and then it's me and Vishal to take part in product planning, and then all the IT and engineering leads in India. And usually how it works is like product management makes a proposal, or all the
sales or market
together. Everybody gives a feedback to product management. But in the end, they can decide. They can now come up with a proposal, what is part of the sprint, and then we discuss it as long until we find
a compromise.
A compromise.
Yeah.
Yes.
Okay.
So the proposal
it's always a
is
compromise.
estimated.
Yeah. If I realize it in the right way, then you would stay up in front of everybody and say, we would like to do the following, and this is a value for our customers, right? And then it goes down into feature level, etc. Right?
Yeah, in theory, we have again systemized it. So everything is system. So we have different tools. So we believe in tools. So there's something that I or our sales teams find from the market, or our product management finds from a competitor, or our CTO thinks it's useful, because you have to also give some scope for creativity, right? We cannot just be reacting. We put it to the product management team. Salespeople put it in Salesforce. Like if they have an opportunity against which they think this feature will help us, or if we have lost an opportunity to a competitor because of a feature, that goes into that. It's gathered by the product management team. That's a sales input. Then I would say the CTO's input, or the general gut level, you want to think of features from a gut level, that goes in from me or Sudh, anybody. It can come from anybody. We are completely open. But it's still very agile. It has to come through the funnel, and then we prioritize it, and then we look at the feasibility, people challenge it, and then once we agree, then it goes into the Jira pipeline, and then.
So we have a thing called feature requests in Java.
Yeah.
This is our backlog. We have currently, I think, about 150. Different detail level, and then they kind of move whatever is all the feature requests into the sprint. Right. And we create stories from it.
Okay.
We have still, I must say we're truly agile. We have, if you look at, and I could be wrong, plan versus what we deliver in every release, sometimes could be, the variation can be has 40%.
But we did the retrospective.
Okay.
Actually, on Friday.
Okay.
So 75%.
Which is actually very good.
We met the plan, and 25% unexpected features.
Which I think is
That's
very good. Yeah.
Yeah.
So it is a classic. So we follow very agile methodology. It's not like following a process, but it's still very agile. We don't wait endlessly. We don't disturb our release cycles. We don't disturb our testing cycles. We have to react fast, and therefore tools are very important because then you can measure, and you can track. So in general, we are a very agile development organization, and we use tools to enable us, because that's what it is. People assume process drives the company. You can be an agile, you can follow an agile process, but you can still be a very slow organization. Or as companies say, I'm on a digital drive, but it's not digital. I think that helps.
Yeah. Okay. Cool.
Allison?
This was a perfect handover then. Next step.
Yeah. And thanks for listening. And
One last question. So one of the real pain points with SonarQube that I have is false positives. When you add new code analysis, how do you ensure that you don't trigger a lot of false positives on the customer?
our concept is very different to Sonas. You're not so much looking at the issue level, but what we invented is called Gamma Score. So we have our own way on how we prioritize issues. And it takes different inputs, like it looks at code issues, at metrics, at design problems, at application, and brings it all together into its own ranking. This means there might be false positives on the code issue level, but if you aggregate all these different metrics together into our prioritization, those are the actual problems that come up.
Yeah, I would say we are fairly confident that when we surface issues, they are actual issues. Because we triage the problem. We don't just look at the problem, not the problem. I think Sonar is a great tool. They do some really good stuff. But they look at it from one perspective. So they look at code issues, they look at duplication, which is great. But the whole relevance mapping, correlation, prioritization has to be done by the developers. We flip that around. Our platform does it. So we do, in addition to what you get in the market, we also do design analysis. And our approach of entry point into code is see how it is structurally designed. And then we see, based on certain design anomalies, how the code issues impact those anomalies. And that approach has worked very well for us and for our customers. And that's what is the big benefit for us. And therefore, we get that question about false positives. So I think 99% of the time where Gamma's used or has been tried, the issues that it has surfaced are actual issues. And sometimes surprisingly see it. And we've seen this even not just in an enterprise environment, we've seen this with some of the largest chip manufacturers in the world. For NDA, I can't share who, but they use the best tools, and then in their assessment of our platform, we've surfaced issues which the best engineers said, actually, that's a good catch, because of the approach that underpins the algorithm of our algorithm.
The challenge for us is that we integrate a lot of external tools as well to enrich our data. So we get data from SonarQube, from TeamD, Findbugs, like this. I think 30, 40, 50 different tools that we work together with. And in addition to our own ones. Some customers want this tool, some customers use this one, they still want to keep it. And those tools very often give us false positives, because we cannot control what those tools output is. And our rating is how we deal with it. So because if you look at it from a higher level, those false positives don't really matter. Because as soon as it's a hotspot from all these different perspectives, it is a real issue, even if it has two false positives in it.
So an example is, from the financial world, how do you rate someone's credit worthiness, right? Earlier, you could just rate it using a bank statement or like this is a balance sheet. A balance sheet is a good data point, but then if you throw in other indicators, then you get a better idea of someone's credit worthiness or organization's credit worthiness. And that's what we've done. We build, in addition to what's it, we build our own data points, which makes it awesome.
Yep, I guess we have to switch over.
Yep.
But I'll be here later.
Okay, normally we have open round now, but I think we make a short break. Take something to drink, something to eat, and later we will start with Safe DevOps and take a look from the other side to the Agile part.
Perfect. Before we do this, I need to hand over one nice.
So I will, after the break, I will take
Mark,
sharing is caring. Run, Marcus, run.
Music?
Yeah.
Die Tools, die wir integrieren, die wurden auch viele Vorträge als inkorrekt eigentlich. Tool sagt, das Problem
Yeah, but I teach spin, I don't know.
genau. Problem ist eigentlich nicht.
I teach spin. I don't know if you want
Das
to
ist
use
halt
it.
nervig.
I don't think I'm any better. Like hard to do mine.
What is spin?
I
know spin 7.
So you're on a stationary bike, really loud music, and lights, and it's dark.
Man beschwert sich rauszugehen, das ist außerhalb von gar kein Problem.
Yeah.
You're in front of the stage.
Yeah, I
What do you
teach.
do? Looking running towards the crowd and they will. You're like a salvation.
And it's my workout as well, so.
Okay, try it.
Yeah, I'm gonna bring everyone to the office. Corinne comes, 3 to 4 times a week. Yeah. That's why on Wednesdays, I come in later. In the morning, I work from 7:30 to 9, and then I teach from 9:30 to 6:40, and then I take a quick shower. And then Tuesdays, 7 a.m. Fridays, 12:15, except for this Friday. And then Saturday, 11:15. That's why I mean, my playlist are like remixes, techno, but I usually rely on Spotify Live. They're pretty good at categorizing, so that's the same with that. But my playlist are like, here's a nice reflection song, and then there's like a yeah.
You guys not drinking anything?
Did your shares go down?
Second time.
Kennst du das?
Den Hebel mal nochmal runter. Ich glaube, der Mechanismus ist
Startup Bring.
Das auch haben, ist sowas, wo man mit einem großen Laden anfängt und dann nach dem ersten Laden bei die kommt. Auch das hat immer die ganze System abgebildet.
Joke. The green juice I bought today that I have every day.
Wir wollten mal mit so Glas.
So, genau.
I am really so much better online now with my friends.
Wir waren ja zusammen. Aber nicht skaliert den Preis verkaufen. Wir machen ja eher.
Testing, but with the distributed then they start Scrum, but not really Scrum. And then after half a year, they say, that was a different perspective, right? Because you have to present it the right way. Yeah.
Wir haben so einen Vollschnell. So nicht telefoniert, aber jetzt mal in dem Auto unterwegs war. Ja, genau.
Oh, it's open now. It's the code. It's warm.
This one, right? The green one, I have. Ich hab noch.
Jetzt
einem dann im Nachgang aufgezeigt, was in der Vergangenheit alles schief gelaufen ist, was eigentlich so gelaufen ist, Thema Never Change the Running System, so in der Agilität. Also allgemein
Das ist meine eine, da kann ich auch einbinden. Ich hätte mir überlegt, so
die Kollegen, die das Teile das hat schon mal jemand vor 30 Jahren schon mal gemacht. Wenn ich jetzt weiter spende,
Ich sehe das momentan auch mit Leute wollen du kannst aber eigentlich ganz morgen einen persönlichen Termin noch einstellen. Und da wäre es eigentlich gut, wenn man sagen würde, wenn man eine Founding von da bin ich noch nicht an die das ist der Grund, warum ich sage, ja, das ist nicht gewesen. Die besten Dinge zwischendurch wollte ich nicht ich gebe noch mehr Belastung. Wenn gerade ab, weil die 7 Features nicht verbinden. Request mit eingibst, der automatisch ja, nee, aber dann aufsetzen zum Beispiel.
Unser erster
und wenn ich natürlich beide läuft, besser dort, als wieder das Feature liefern und dann irgendwie ein Test oder eine Testmarke aufgesetzt, dann das Ergebnis davon vielleicht dann ein halbes Jahr später. Und muss dann noch mal dann tut es mir dann noch mehr. Am Anfang bei der Entwicklung gebraucht.
Ja, du müsstest quasi immer wieder automatisch scannen laufen. Alle, keine Ahnung, Stunde oder wie auch immer oder jeden Tag automatisch besser laufen. Ja, dann habe ich alles richtig, aber ich wollte programmieren.
Ich will es auch wenn es automatisiert belegt, da wäre das irgendwie gut, wenn man was wo man nicht, ich meine, das Problem hat ja jeder. Eigentlich jeder auch aber warum muss ich denn warum muss ich jedes Mal und wir haben nicht die Möglichkeit, uns mal eine Woche zu nehmen, irgendwie es aufzusetzen. Also Woche irgendwie muss man auch was geben, da investierst du Tage und ja, aber das ist ein Projekt, habe ich das zur Fitness gearbeitet, hat er geschrieben, was passieren soll. Und dann haben die Entwickler das halt genommen und das dazu geschrieben. Das hat er auch passiert, mit Raspberry und wenn die Teststelle umgekehrt sind, ist die Abwehr gewechselt und so. Und du hast es halt sofort gemerkt. Und das war nicht da. Also wie auch vielleicht ausgeliefert worden ist, haben wir irgendwie 2 Bugs im Monat. Das gleiche, ein anderes Teil des Produktes, da hast du 100 Bucks im Monat. Also, ja. Und was halt auch so, wenn man schwer abhört, also die waren so richtig Fernsehen, aber ich habe darüber irgendwie andere 3 Stück, weil wir hatten dann mit immer irgendwie ein anderes Produkt dazu, und dann gehe ich da rein. Wenn da mal was, wenn da einer was morgens verbunden war, dann muss man das natürlich auch. Also das will ich eigentlich gerne immer nutzen, aber es ist halt sehr aufwendig.
Kannst du diese Idee schon in der Tasche?
Ja.
I'm sorry.
Das ist genau das Richtige.
I would sleep on, I don't know, wait. She will eat it.
Yeah,
Yeah, she will destroy it.
So guys, please find a seat. Ja, klar, aber der Hund kriegt dann immer wach.
Okay, remain standing.
Wait.
It's fine, it's fine. It's fine. That's okay. So, Peter already introduced in the introduction, raised the question, DevOps and SAFe, agility, and DevOps is a big hype, big buzzwords at the moment in the market. Do they fit together? How do they fit together? And he already answered yes. They have similar roots. And now I want to show you how they fit together. And if when I in this context refer to agility, I'm talking about the Scaled Agile framework, the SAFe, which is, you have the big picture there. Anyone who has never heard Scaled Agile framework? So very quickly, I will give you a deeper introduction afterwards. It's basically a framework for scaling Agile principles from Kanban and so on and so forth in bigger contexts, in large organizations where you have product development departments with more than 80 or 120 developers. Okay, that's okay. For now, that's enough. So, and the ultimate goal of both is generating higher customer value, and we made the experience that they basically go hand in hand. And since the beginning of the year, DevOps also appears on the Agile framework. So now we started very technical. I want to do a little bit lighter to digest now. We stay on the business side a little more. And even though you are engineers, software developers, I think it's very useful for you to know what your potential customer knows. SAFe is the biggest framework at the moment, and it's applied in huge organizations. And if you work there, that's what they understand of DevOps. I think it can be very useful for you as well. Okay, a few words about myself. My name is Caroline. Originally, I studied finance at the WHU University, just around the corner, close to Cologne. And I became passionate about numbers first and then about agile working. So I did my master thesis on agile product development in the financial industries. Then I joined KEGON AG, did my SBC, RTE, and Scrum Masters, which are role-based trainings and licenses. And then now I work as a junior agile consultant at, for example, Robert Bosch Multimedia, which is a huge development organization, or our Media, which is a smaller one, but still large enough to apply SAFe. So let's start. First of all, I want to give you a short introduction overview about the problem to be solved, how SAFe and the Scaled Agile framework understands the DevOps problem. When we go to a customer, we see something like this. We have the business side, we have the development, and we have the operations. historically it has been like that, and we have kind of walls behind that. They are organized in silos. They kind of barely communicate with each other. The first wall has been solved by Agile. Agile has made the business and the development communicate very closely. The second one now is solved by DevOps. And this is what I'm going to talk to you about now. So if we go to a customer, we find something like that. We find people, they say, okay, the business needs more features, the competitors is much more innovative than us. We need to do something, we need to develop more things. Let's go faster, let's go quicker, let's do more things, let's be more innovative. On the other hand, we have the voice like development is constantly breaking production, we need stable environments, we want to make our existing customers happy, they are complaining all the time. Let's go slower, we need more stability. How do you align this? It's like completely opposite goals, right? And now, who is DevOps? Who are these voices? On the one hand, the ones that say, okay, we need to go quicker, we need to be more innovative. It's the development. And the other side is the operations, traditionally in the software context. Now, SAFe wants to be a framework that is universally applicable, not just only in software development companies, but also in other industries, other branches, other departments. So they extend this definition to development, operations, but also business, also security, compliance, or architecture. I mean, compliance or marketing, they have to deal with the stuff you are developing later on as well, right? So it makes sense to include them in the whole process of DevOps. So as I already said, there are different groups in the organization, and each and everyone has different, or in the most extreme case, opposing goals. And then the lack of alignment means the different efforts cancel each other out. It's quite easily and quite nicely illustrated there. If everyone, they can be very powerful, but if they go in the opposite direction, you end up with a flat zero. And this, in the long run, goes maybe, I don't know, 3 months. How long would you work in an environment like that, where you basically make no impact at all? So this is very, demotivating. It creates a feeling of constant work with little or no progress. So in the SAFe context, we want to, the most critical goal is building this alignment.
Yes, because everybody would like to be the group who makes big impact.
Yeah, sure. And I think if you could combine that, how powerful could you be? I mean, if everyone would work in the same direction, that could make a huge impact.
So it's about aligning people's goals.
Yeah. How does the Scaled Agile framework define DevOps? It says it's a mindset and it's a culture, so it's a really a mental state. But it's also a set of principles and technical practices. So the mindset is expressed in the technical practices, but you need both. If you only apply the practices, it's like an empty body. You know, if something extreme happens, then you quickly fall back into old patterns, because in extreme situations you don't think. If then it's not in your culture, it's not in your DNA, it's useless. And then the ultimate goal: faster, routinely, and reliably. Faster development, routinely and reliable stability. Excuse me. So you basically have this match of opposing goals. And then we have, how does it do that? With communication, integration, automation, and close cooperation. We will go into all of these verbs later on as well. And most important, among all the people, everyone, marketing, business, and so on and so forth, in order to plan, develop, test, deploy, release, and maintain a solution. So we have the whole value cycle, the whole life cycle of a product in this definition of DevOps. Very important as well. Okay, the CEO, you presented this set of slides to the CEO. He says, okay, great, we now have you, and you are the DevOps team. Go do it. Doesn't work. Really doesn't work. You can't say, okay, you do DevOps and the rest is will be doing the stuff like going on. You really need to integrate this DevOps idea in the whole value stream, from the beginning to the end. And it only creates real value when the end customer can operate the solution. not only the development, but the end customer. So you really need to integrate marketing, security, and so on and so forth. DevOps isn't optional. It's only important. The only question is how efficient it is. Challenges in the organization. Lack of test, build, and deployment automation. Like, production, yeah. Production defects not caught due to mismatched environments. You want your testing environment to be as close as the final environment. I will go into that later as well. Large batches of changes are pushed to production, causing the Monday morning effect. So you have these huge releases, and of course the chance that there in this huge batch of code is an error, relatively high, right? It's higher than if you just try smaller batches and then you can test them immediately.
Only if you don't use Gamma.
Sure.
For other was called Friday night effect.
Yeah.
I used it to do production deployment on Fridays.
Yeah.
Don't do it anymore.
Then lack of communication about end user problems and needs from operations to development. I mean, this is obvious, right? How can you as operations complain about development mistakes if you don't tell them? How should they know? I mean, you need to communicate what you need. And then, of course, lack of trust, which is the worst state. I mean, trust, this is very difficult. This is, I think, the highest escalation that is possible. So suppose you like it and you apply DevOps. Now I have this mouth-watering slide for every executive. What can the results be, right? This is taken from puppet.com. I highly invite you to take a look at it later as well. I think each year, they look at successful DevOps implementations and they try to put it into numbers. I said I study finance. I'm much more convinced by numbers. So what can you achieve by applying DevOps in your organization? 440 times faster lead time. Who doesn't know what lead time is? It's basically from the beginning, the time from the beginning of the process to the end. So you can, it's a really increase in speed, right? And this, if you look into the market, you can really be ahead of your competition from a business perspective. 96 times fewer defects. So it's also a quality improvement. And this results, of course, you have more time that you can spend on your work. So you are quicker and you spend more time on your work. So twofold effect ahead of your competition, right? You can read it by yourself. These are all very technical aspects. Now, two business aspects that I want to highlight as well are the last two. 2 times more likely to exceed profitability goals. So this is real cash. The introduction of DevOps translates into real cash advantage. And from the HR perspective, I think every company now has the problem that the job market. I just entered the job, entered and got out of the job market, and it's very easy to find offers for highly educated people. I think no software engineer, no good software engineer has a problem to find a good company. But the companies have problems to find good engineers. So if you have this DevOps culture, apparently the net promoter score by the employee net promoter score is improved 2 times, more than 2 times. So I think it's an idea worth thinking about, right? So
But this is only about DevOps. It was held Agile included here.
No, it's only DevOps.
Only DevOps.
Yeah. As I said, take a look at the paper. It's very interesting. Now we come to Scaled Agile Framework. You have seen all these benefits. How stupid could they be not to include this highly innovative, super duper idea into their framework now? How are they doing it? DevOps in SAFe is integrated by principles. As I already said, it's a framework, should be universally applicable, so they don't give you a cookbook, they don't give you a recipe, but they give you principles and ideas in order to enable you to make the right decisions. So it's important to understand the principles that when you want to apply this idea in your context, of course you have to adapt it a little bit, but you know, I want to go into this direction, so I can do some things, but I can't do other things. I really have to understand the principles.
So it's not a separate process.
No, it's in the safe agile process. I will come to this right now. First I want to introduce you to the principles. The first one is culture. I already said, okay, we have development and operations together. So we have a shared mindset, shared responsibility. Everyone operates the solution together. If you tell a developer you have to maintain this piece of code for the next, I don't know, half a year, he will do it right the first time. Right? He won't do crappy code. Automate the continuous delivery pipeline. The manual work is very expensive and very time consuming. So if you standardize your processes and automate, for example, automated unit tests, that was an example, it gives you advantages in speed and also quality, because mostly machines are not as error prone as humans. Lean flow, which is taken from the Toyota production system. I think lean is everywhere right now. Small batch sizes, limited work in progress, and extreme visibility. I will come back to that later as well. Measurement, we want to continuously improve our processes. And gut feeling is always a little bit difficult because everyone has, it's differing amongst all of us. So if you measure things, you have really a reliable basis for improvement, and you can really spot whether you are improving at all, where are the low-hanging fruits. So you need to architect for measurements as well. And the last one is recovery. We want to be an innovative company. We want to be able to change the systems, develop new things, and do experiments. But experiments can go wrong. So I always need to have the opportunity to have quick rollbacks, to quickly fix something and recover our code. Let's go a little bit deeper into it, the culture. I already said culture of shared responsibility for development and deployment. DevOps requires a tolerance for failure. And this is really a leadership thing. Your people need to be allowed to make mistakes, otherwise they won't try new things. Rapid recovery and rewards risk-taking. The last one is sharing discoveries, practices, tools, and learning across silos. I already said sometimes there is a lack of trust because the gap between development and operations is historically so big. They have so many struggles. They are not readily willing to share knowledge, share practices amongst each other. So DevOps really brings them together, and they need to communicate. They need to share the insights they made in the past.
Especially the second one,
Yeah, sure.
failures, risk-taking. If you go to operation, they say girls, take no risk. It has to run. Otherwise, burn.
Yeah, because I mean, it's also about compensation or like the reward that they get, the bonus that they get in the end. I mean, individual bonuses here don't work really well because it's difficult. And of course, if you reward this behavior also materially, it's difficult to get it out of
It's not just bonuses, it's who gets woken up at 12 midnight when something goes wrong.
Yeah. Okay, so I think you get the idea, right? Next one is automate the deployment process. And I think you are much deeper in the topic right now as a software engineer. Nevertheless, I want to show you 5 points that SAFe makes as a suggestion for how to automate your processes. The first one is match development environments to production to the extent feasible. So I think it's also a cost question, whether you can afford the same environment that you later use for the customer, but it's about finding the right balance. The next one is pretty similar, maintain a staging environment that emulates production. Same idea. Deploy a working system to staging every iteration. We also already know Scrum, which uses the same principle. Here in SAFe, we have iterations as well, which are on the train level a little bit longer, on the team level 2 weeks as well. And we want, even though in SAFe we work on one product with several teams, we still want to have a working system at the end of every 2 weeks, which we integrate together. So we really want to make sure that it works, and we really want to make sure that this automatically works. Last one, automate deployment, everything under version control. Automatically build environments. and automate the actual deployment process. Okay? Just, as I said, I'm sure you can come up with so much more examples, but this is suggestions.
But isn't this the norm now with companies? On an average? Just curious.
I work at Bosch Car Multimedia, and they don't apply this at all. Or AOE, they don't have this automation at all. If you should join us for the DevOps training, where you work with on this topic more intensely in 2 days, and you would be surprised what's actually the norm in the industry at the moment.
Why do you think that is the case? People's aversion to change?
I don't know.
Yeah, sometimes it's regulation.
But you have to be safe.
Not only that, you have to document every single step.
Mm.
And somebody says, well, you cannot deploy this in production.
It's not signed off.
Because somebody has to build a document for the dev version before it goes in production, and you have to put the requirements and what it does, and blah, blah, 6 months later you put it in production. So this may or may not apply in all cases.
That's what I was.
If you're in the risk department, forget about it.
Yeah, I think that seems like a valid point here. Next one is focus on lean flow of value. As I said, the idea is taken from the Toyota production system. We want to continuously develop and release small batches of value. This is done by identifying bottlenecks to the flow of value. We want to improve our development process, and bottlenecks are the most they make the most impact on the whole process. If you solve them, you generate much higher value in the end than working on some minor things. Decrease the batch sizes of the work. As I said, small things go through the system faster, more easily. They can be automated eventually, and it's lower risk. And then manage and reduce queue lengths. So I think for features, they have requirements, they have a certain value, but this value is perishable. It goes away as the customer changes, the competition changes, the market changes. So the development process itself depletes the value of the feature that is produced. If you now add long queue lengths, problematic. So try to have short queue lengths. I actually have a short video that I now want to postpone to the end due to time constraints. If that's okay.
It's a clock, right? Yeah.
Yeah, there's a clock. It basically shows how batch sizes impact. Can we show?
Yeah.
Okay.
Yeah.
Yeah. I can show you the first part and the last.
What do you mean? So batch size is affecting features?
How much? Yeah, how big your features. Okay, let's show it. Here in the first, we have very large batch sizes. So the batch size is this 10 pennies. You have to finish those 10 pennies before you can go to the next step. So you have a really large feature, really large chunk of work that needs to be done until you're going through the whole process. And the time that is taken, that is going up, is when the first penny arrives at the last station. So when it's basically the lead time for the first penny.
So from what I'm saying, like the problem is that in certain organizations, features cannot be broken down.
Yeah, it's a good point. It's a challenge for many organizations to cut their features correctly. That's right. So see one, and so on and so forth. I think you got the idea of a large batch size.
Takes a while.
Yes. Now I want to show you the last one. The second one is already. Which one is one? Got the idea, right?
Yep.
So this is one example for lean flow, how you can improve your lean flow. In SAFe, we also do something like a value stream map. The value stream in SAFe is basically the metaphor for the steps that, the metaphor for the steps that some piece of functionality needs to take until it reaches the end customer. So it's basically another word for the development process. And we map the value stream in order to improve it. So to understand, first of all, understand how value flows through the enterprise and the different functions of business. Sometimes we are not even aware how many people are working on our functionality. It may be software, may be something else. Gain insight into organizational effectiveness. Identify bottlenecks to the flow of value, that's what I mentioned. Understand how we can improve the flow of value, and finally, be quicker, be faster, have a faster time to market. How is this done in SAFe? We first identify the steps. This is just an example for software development. Feature definition until the production sign-off. I mean, probably you know the steps. Then we identify the people. Can be PM, the project management, teams, developments, and so on and so forth. And then we identify the measurements that we need to take. The first thing is lead time. As I said, the time that passes until it ends. It begins here. It's like these are finished until it ends at the next station. And the process time, the actual working time. So the lead time minus the waiting time. And then we have as last number % complete and accurate, which is like a quality reference. It says how much of the work that we deliver to the next station can actually be used. Okay? Yeah? We can do that for all steps by talking to the people. Some organizations have measurements in place. And then we can take sums of everything. Total process time, total lead time. If we divide one by the other, we have the activity ratio. And if we multiply the complete and accurate, we have the rolled C&A, which is the quality indicator for the process as a whole. Then we come up with numbers like 5%. So we actually, of the time that a feature spends in our process, we only work 5% on it. And 95% it spends waiting. And now I tell you the value of a feature is diminishable. And it's very quickly diminishable. I think it's 8%, 3% every month, something like that. So it's like, this is a problem. But this is the reality in a lot of organizations, 5%. And then 36% of this 5% that get through it, 36% is usable. I think these are very shocking numbers, but this is the reality in most organizations.
What are our numbers, Marcus?
Here, right?
What are our numbers?
Yeah, it makes sense. You can map it. It's an easy task, actually. You can do it in a workshop with KEGON or by yourself. Just try it. It's very interesting.
1,800 hours are 200, more than 200 days.
Yeah, it's more than half a year, right?
Yeah. So
Should
you
do that,
don't need
Marcus?
the feature anymore.
Yeah.
To wait this
This will be interesting for us.
I mean, we do 1 month.
But feature throughput?
Yeah, at least like the activity ratio is maybe interesting as well, right?
I think this varies a lot between different business sectors, but I think this would be right for something like automotive.
Mm-hmm.
They do that actually. They have the V model there.
Yeah. I think it's very interesting. I like numbers, as I said. So, and then wait. Of course, you can identify the improvement steps as well, right? For example, here you have a lead time of 700 and a process time of 400. So this would probably be the first step where you
Quick wins.
Yeah, exactly. Next one is measurement of everything. We want to continuously improve, therefore we want to measure everything. Store logs and ways that enable analysis. So your data needs to be you need to be able to analyze it. Different telemetry for different stakeholders. If you throw a whole bunch of numbers at people, they will run away more quickly than you can find any interesting stuff in there. Collect data on business, application, infrastructure, and client layers. So on the outcome. but also collect data about the deployment pipeline itself. That's what we just did with the value stream analysis. Broadcast measurements tell people what you are finding out. It's just do just this at the client at the moment, and they don't broadcast. The people know you are measuring, but they don't tell them why they are doing it, how they are doing it, for what purpose, and everything is like they get fear, they get scared because they feel measured. And then by chance, really, it was a situation we fired a Scrum Master.
Yeah.
So now it's
Agile lead of me said one time, if you are a good Scrum Master, you are every time you are with 1 feet on the fire.
Yeah, and now the project got very difficult because we just tried to measure for improvement. But it was by incident that the Scrum Master got fired, and now we don't get it out of the organization anymore. It's very difficult.
So can't you measure it from Jira?
Sure, but it depends on what you're measuring. Like, of course, you can measure
you can see
process things, yes, but I always prefer talking to people as well. So, and the Flurfunk is so quick. The gossip, it's crazy. Most organizations, it's very.
The risk of measuring things is that every metric can be gained. As soon as you set up, you got to.
But this is also a cultural question, right? If you can design your numbers as you like, if the CEO pushes you to in a certain direction. So the leadership is not covered here in my slides, but of course leadership is the overarching. Exactly.
What about the workers' union?
I was about to say,
how do you handle that? If you can't overarch a nation, right?
Yeah.
So if a nation is fundamentally wired not to be measured, not to measure developer productivity or worker productivity, then how do you do it?
I'm doing it in 3 layers. One is the actual pipeline measurement, like how fast, but very basic, very, very instead of having 100 metrics, just 1 per group. And then you have operational KPIs, like at the end of sprint 5, what operational impact have you achieved by going through 5 sprints?
So how do you measure operational impact?
Every sprint, every week we have product owner meetings, and at each product owner meeting you ask what is the current status of the sprint and what is happening in each bucket, one by one, and then final is the high-level business KPIs.
Could be an answer to our previous question, why it's not applied broadly in the industry.
I was very clearly, openly warned that I cannot choose KPIs that can remotely even connect to an individual's performance.
Yep.
We're also working on OKRs, objectives and key results at KEGON, and we have the same problem.
We can do. I think there are some tasks where you can measure. Like you can say, I can't measure developer productivity, but I can definitely measure the quality of your code. Because there's no excuse that your code's crap. You can do what you want, I don't care. You work 1 hour, 10 hours from your home, but the code is a very tangible output. And I think in software it's a bit easy, but I understand because of this, and I could be wrong, that Atlassian apparently deprecated their API where you could track the developers' productivity in Europe. Can you imagine? That's actually because we had a feature that worked with it, and they deprecated it after GDPR came, so we had to remove that feature. It was a very powerful feature, actually. It was for developers to help developers, but because it was measuring something about developers, which came from Atlassian, we had to deprecate it. So we might bring it back, actually.
It's up to the company to use or not to use.
Actually, Atlassian deprecated it here, so but we can use it in US.
One more thing about measurement, measure lead time and process time of the whole process. Oftentimes we find something like we measure everything. This needs to be approved. This needs to be like high end, high edge, and then it lies somewhere here for 3 months. And as we said, with the value stream map until it's released, look at the whole process. Funnel, if you have ideas, it's just a collection of ideas, and then they are analyzed from the lean startup cycle. If you analyze whether you want to do them, prioritize, and then if they are in the backlog, they are ready for the implementation. But sometimes you have, for example, ideas or customer feedback that needs to be evaluated whether it's really useful for being done. And then you can apply something like MVPs, minimum viable products, and I will come back to that later.
There was a question?
So think about lead time. If you measure it up starting with funnel. Yes, okay.
It's suggested there, but only if you have a funnel process in place. Like if you.
Okay.
You can also graphically maintain your data, then it's more eye-pleasingly broadcasted. For example, this CFD, it's more easily readable.
Is this coming out of Jira?
I'm not sure.
Okay.
I can ask if you want.
Look like.
Yeah.
And then the R in Karma is architect for reusability and recovery. You have the stop the line mentality. Who can use this phrase at all? Stop the line mentality. It comes from the Toyota production system again, where everyone in the car factory was able to stop the production line when he spots an error or a defect.
Everyone has a red button.
Yeah. And we want to enable our developers to basically do the same and to stop the development process if something really threatens the product. Plan for and rehearse failures. That's very interesting. I mean, usually you hope nothing happens, but that's unrealistic. I mean, errors happen always, and then people panic. You know, especially like operations, they are involved with possibility, and then something happens, or it's in the middle of the night. But if you have a rehearsal for the failure, how to react, then you can be more rational. You can really think, because you lose the ability to think if you're scared. Build the environment for both rollback and fix forwards. That's an architectural question. Like put the processes in place so that you can easily test things, you can easily take them back. You want to always test small things, something like that. And use tools such as feature toggles, dark launches, chaos monkeys. The chaos monkey is very interesting, or canary releases.
Can you explain a little bit more about those Chaos Monkey Canary releases?
Yeah, Chaos Monkey is I think it's a script that was developed by Spotify and Netflix.
It is actually a very interesting, it's come from the software world. So Chaos Monkey is, what Netflix does is they have a team that will just, so as you test a system, they will just go into the data center, they will do anything randomly, they'll pull up the wire, they'll switch off the electricity, they will just do anything that monkeys do chaotically. Your system has to work.
Oh, wow.
So it's actually one of the most interesting testing techniques that Netflix used internally, because they have so many servers. They have, if you look at, Netflix does a lot of open source. They're very active in a lot of development. So Kafka, a massive, and this is what they did, because we think, oh, Netflix streaming. If you read the paper, they have hundreds of iterations on which they stream your video, including your screen size, bandwidth, devices, phones, iPads. And they have to test all those on servers, on low bandwidth from 64K to, and when the testing process, there's something called a Chaos Monkey came from there. So they start pulling up the wire. Your movie's going to pull up the wire, electricity, so they break the computer, the system has to still work, and that's what the Chaos Monkey is. And that's where it comes from.
Exactly. And the last one is to just release your feature for a certain customer group so that you can test. Yes, these are the principles. How are they now applied or implemented into the safe context? You have this big picture here. You have it can be read from top down. You have the team level here, a group of agile teams that's working on one piece of software, and these are summed up on the program level. So we have another agile team, the release train architect, which is the equivalent to the scrum master, the product management equivalent to the product owner, the system architect to the dev team. So this is the safe way to scale agile teams. So we have DevOps on the team level, where they stress the quality. As we said, the quality is very important. The development and operations working together. We have cross-functional teams there, which is agile. So we really see the overlap between agile and DevOps cross-functional teams. But we also have the DevOps idea on the program level, where you have the DevOps culture shared between all teams. You have the automation. All teams use the same automation systems. Mean flow, the value stream goes through the whole product, through all of the teams. Measurement and recovery also apply for each and every team. These are the ideas, and then we have something that is specific to SAFe, which is the continuous delivery pipeline. The continuous delivery pipeline is something, it's another word for the value stream, but shortened on the development side. It's basically just the development process. Another word for where the value flows through. It's a synonym metaphor something. How does it look like? The continuous delivery pipeline has 4 parts. First, the continuous exploration. We somehow need a source for our features, for what we want to do. So we explore the market, we do gamble walks, get out of the office. Customer feedback can come from everywhere, which is the funnel basically. Then it gets analyzed, evaluated, maybe with a lean startup approach. And then if you want to give it a go decision when it comes to the integration, then it gets implemented, it gets coded or developed or something like that. It gets continuously deployed in the environment, and then it gets released on demand. So we want to continuously deploy the software. We want to always add new value into our working piece of software, but we only want to release it to the customer when he needs it. How that is done, I will come back to it. Again, this lean startup cycle, we already discussed it. It's a continuous exploration. We have this epic, we have this idea, we build the MVP, we evaluate it, and then we either pivot and stop, or we persevere and we add additional features. And ideally, as I said, we want to measure everything, so we also want to measure our innovation. And ideally, it looks like that our hypothesis tested go up over time. So we want to make more ideas, generate more ideas, get into the habit to try things out. And ideally, this gap between hypothesis tested and hypothesis failed gets larger over time, so that our successful innovations become a larger share over time. That we get better, that we understand our customer better as well. Continuously integrate the components, so we know what to do. Now we need to find out how to do it, and we want to continuously build, test, end-to-end testing and staging. This is the part. And how is this done? If you want to do it continuously, we also need to continuously be able to test things. So we need to architect our infrastructure for testability. Systems that can't readily be tested can't readily be changed. Right? If we want to change something, we need to test it. And if it's very, a lot of manual work, the hurdle to change things is much higher. All jobs require less time as well. Common DevOps patterns is loose coupling, APIs, microservices, containerization, and stranglers. I think you can explain it much better than I in the aftermath.
I've never heard of stranglers.
Yeah, that's a new one. But others, stranglers probably would be bottleneck services that just choke up.
Bottlenecks as in performance, or
could be anything. Could be way your functions are designed, or methods are designed, or classes are designed, where you can use them. What we call anti-APIs.
Anti-what?
It's called completely opposite of APIs could be stranglers, right? So use APIs for efficiency, but that's a bunch of things which actually could be. I don't know how to read up.
And I said that there's no DevOps team or no DevOps expert expert in the organization, but Safe introduced the system architect. He is responsible for the infrastructure environment, so he's the person taking into account those questions. And he also needs to architect for operations, so he's responsible for the operational needs, build the telemetry, that I'm able to measure things. If I don't build it into it, it's difficult. Allow service to be downgraded or even removed in times of high loads or in response to incidents. I think load balancing was one subject that falls into this one as well. And build the capabilities for fast recovery and fast fix forward. These are, we recognize the principles that we just addressed, right? Also done by the system architect. He's responsible, that's wrong, he's responsible that it gets done. He doesn't need to do it alone. So let's frame it this way. And as I said, all of these things, the continuous integration is really cross-team collaboration. We have cross-functional teams. Production issues are everyone's responsibility. It's not the same person that gets woken up in the night. Everyone or alternates or something like that. Having a team that can develop and support is preferred cross-functional teams, as I said. And it's basically the same. Solve production issues and identify root causes. I already said, okay, if you continuously integrate, we have we still work in sprints, also in the scale environment. So even though each team works autonomously on a part of the features, we still have a big working piece of software that's the sum of all teams' efforts at the end. So the system demo is basically the review on team of teams level. Again, if we have done this, we have this full stack telemetry. Application should clearly log and report meaningful activities and events. Infrastructure should support this, and we want to monitor technical and business data. So repetition. And then, if we have the system demo, we have put it into production, but not released to the customer. So we want to separate deploy from release, so that we can, for example, before Christmas, we can offer something, or we have a